Good day to you all. Welcome to the first lecture of tanker operation lecture series. Today we'll discuss about cargo calculation in tanker. Let's begin. So in tanker, there are different methods are used to measure the quantity of cargo on board. Normally, we see that the surveyor, they come on board, they take the ullage of the tank and they get the volume. They do the calculation and they get the volume. Sometimes to get the weight of the whole cargo, the surveyor they just check the draft and uh, they get the weight, from lightweight, calculating the lightweight and load weight, they get the full weight of the cargo, right? But to get the precise weight of the full cargo or precise volume of the whole cargo, actually the surveyor they go for the tank survey method. They get the ullage. What is the ullage? Ullage is the distance between the tank top and the top side of the cargo, right? That is page is called ullage. So the surveyor normally they check the ullage and they calculate the cargo, and while they are calculating the cargo, they calculate the cargo in these three methods. The first method we call it the calculation with density. The second method is calculation with specific gravity. And if you go to the USA, they most of the time they use the API method, and they they take the API gravity and they calculate by API method. Right? We'll discuss all the three methods in this lecture. Don't worry. Let's begin with calculation with density. I want you to note it down. This step here. I'll discuss all the steps one by step. Then I'll actually practically show you how to calculate the cargo weight by calculation with density. Right. So first thing first. The first thing is that you need to get the density of the cargo in vacuum from surveyor at 20 degrees Celsius, right? Once they give you the density of the cargo in vacuum in 20 degrees Celsius, what you need to do, you need to find the density of the cargo in air at 20 degrees Celsius. How you get it? You just subtract it by 0.0011. Once you subtract that one, then you get the correction factor per 1 degree Celsius from surveyor. And once you get that one, actually you calculate the correction factor at discharge temperature. So suppose your temperature is while you are in the discharging port, the temperature is 30 degree. In that case, you need to calculate the correction factor for 10 degree, right? Because you have got 20 degree density, and you just need to get the correction factor for 10 degree, and you just add or deduct as per the surveyor's requirement, and you get the density of the cargo in air at 30 degrees Celsius, right, in that discharge temperature. Then once you get the once you get the density at discharge temperature, what you need to do, you just get the volume of the cargo from the ullage table and you correct it uh, uh, due to trim and list. So most of the time when you are in the discharge port, you'll see that you are 99% time you are just upright, and you may have slight trim, maybe maybe 0.5 meter to 1 meter. You just do that correction from the ullage table, and you just get the volume. And once you get the volume, you just multiply with that volume with density and get the weight of the cargo, right? So these are the different the steps actually you need to follow while you are getting the full weight of the cargo, right? Let's take an example. So for the example is that from ullage table you have received a volume of cargo at 30 degrees Celsius is 900 meter cube at discharge port. So this 900 meter cube is after your correction, like trim and list correction, and a surveyor provided you the density of at 20 degrees Celsius in vacuum is 0.8605, and correction factor per 1 degree Celsius is 0.00042, right? So you need to find the weight of the cargo. How you do it? So obviously here we just keep the pro forma how actually you do it. So I have given the 7 steps over here, and let's do one by one. So we have got the density at 20 degrees Celsius in vacuum is 0.8605. What you need to do, you need to subtract that correction 0.0011 from the density in vacuum, and you get the density in air, right? Once you get the density air, what you need to do, you need to get the correction to observed temperature. So what is your observed temperature? Your observed temperature is 30 degree. So what you need to do, you need to multiply that the difference between observed temperature and 20 degree. So it is 10. So 10 into 0.00042, that is the correction factor the server has given you. And once you have got that correction factor, what you need to do, because your temperature is increasing, so what will happen, you decrease for that cargo, the most of the time the density will decrease, right? So you get the density in ER in 30 degrees Celsius, and it is 0.8552, right? So once you get the density, it is very easy to get the volume, because you have it is easy to get the weight of the cargo, because you have got the volume. Volume is given 900 meter cube, and from where you have got this volume, you have got this volume from your LH table, and after you get the volume by LH, you just correct it by trim-and list, and you just multiply with the density, corrected density, and you get the weight of the cargo. So in that way, it is you get the final weight of the cargo. So it is very straightforward, the calculation of the density, right? So you have got another example over here, another example over here. Just I want you to practice in your own time, right? You can take a picture of that one, and you just practice in your own time, right? So they are the different, and I have given the answers for those as well. Let us see how the how you calculate the specific gravity. So here actually we have got a specific procedure to follow. I want you to write down all the steps how actually get the weight of the cargo by using the specific gravity. So what you do, the number one step is you get the specific gravity at a given temperature, right? And from the surveyor, right? And then you get the density in vacuum at the temperature. How you do, actually you just multiply that specific gravity with the correction factor, right? From where you'll get the correction factor, I'll let you know, don't worry, right? So this correction factor is basically is a fresh water density at the temperature, and where you'll get that one, I'll let you know, don't worry. And then once you get the density at vacuum, then what you need to do, you just find the density in air at the temperature. And how you get it, you just subtract 0.0011 from that density, and get the correction factor from the surveyor for per degree Celsius. And once you have got that correction factor for 1 degree Celsius, what you need to do, you just calculate the correction factor for discharge temperature, and finally you get the calculate the density of the density at discharge temperature. And once you calculate the density at discharge temperature, you just multiply that density with your volume, what you have got from your LH table, and you get the weight of the cargo, right? So there is there's the pro forma. So here it is same, just like the previous one, just only one step you need to do. What you need to do, you need to multiply the specific gravity with the correction factor, and that correction factor is basically fresh water density at the temperature, right? So so before starting, let's clear some concept. The first concept is specific gravity. What is specific gravity? So specific gravity is a measure of density of a substance compared to the density of water, typically measured it for 4 degrees Celsius in vacuum, right? So that means it is a it is a comparison between the substance and the water density, and typically we just take the water density at 4 degrees Celsius in vacuum, right? If your specific gravity is more than 1, that means the substance is denser than the water, right? So if your specific gravity is more than 1, that means 1.2, 1.3, that means that substance will sink in the water, right? And if your specific gravity is less than 1, that means the substance is lighter and it will float. Whereas if your specific gravity is 1, that means that substance is as dense as water, right? So the correction factor for specific gravity to density in vacuum is 0 degrees. For 0 degree it is 0.9998, and for 4 degrees Celsius it is 1, and for 15 degrees Celsius it is 9991, right? So what is this correction factor? Actually, these correction factors are the freshwater density at the temperature, right? So this freshwater density of water at 15 degrees Celsius is 0.9991, right? Freshwater density at 20 degrees Celsius is 0.9982, right? So normally you'll get this correction table from your surveyor, or in the STM table, or you just take a copy of that one and you keep it in your CCR, right? And so what you need to do to find the density at a given temperature, you need to multiply the specific gravity with the density of water at the temperature, right? So the density of water at the temperature, we call it the correction factor, right? So this is the formula. So density at a given temperature is equal to the density at specific gravity at given temperature into water density at the temperature, right? So let us do the calculation of the specific gravity. So I have kept the pro forma on my right hand side. We just need to follow the pro forma, right? So what is the question here? The question here is, you are at the loading port, any loading port. It can be maybe a Malaysia, Singapore, right? Anywhere, right? So, and you have loaded a chemical with a specific gravity 8250, right? And so the specific gravity of that chemical is 8250, and after alleging the final volume of your cargo, you have found that 900 meter cube, right? And the temperature gauge, the temperature shows the 30 degrees Celsius. Surveyor provided with the density correction factor per 1 degree Celsius is 0.000081, right? So, and all the data is given in vacuum, right? You need to find the weight of the cargo, right? So why we are considering weight? Because volume, we get the volume from Alice table, and volume can go up and down, right, due to the temperature, but weight will not go up and down. So that's why the weight will not vary. So that's why in tanker normally we just always go for the weight, right? And that weight we just keep write it in the bill of lading, and that's how the industry run, right? So let us see how we do the calculation, how we find the weight. So we find the specific gravity at 25 degrees Celsius in vacuum is 8522. So as it is in vacuum, so we need to convert it to the ER. How to convert it to ER? You just subtract minus 0.11, 0.11, right? And as we know that we have got a correction factor, right? This correction factor is 0.9970, right? So we have got a specific gravity in 0.8520, and to convert that specific gravity to density, what you need to do, we need to multiply that one with the freshwater density at that temperature. That means at 25 degrees Celsius, the freshwater density at 25 degrees Celsius is 0.9970, right? It is a constant. You'll find it in any table, right? So you just multiply that one with your specific gravity, and you get the density, right? Once you get the density, what you need to do, you need to just subtract it with 0.0011. Why? Because the density is on the vacuum, so you need to transfer it to the ER. So once you subtract that one, you get the density in ER. How much is the density in ER? It is 0.8214, right? So after subtracting, right, once we have we have got the density in ER at 25 degrees Celsius. uh, uh, we need to see what is our discharge temperature. So here you see we have our discharge temperature is 30 degrees Celsius. That means it is 5 degree above, right? So we need to find the correction factor for 5 degrees Celsius. So we know that from the surveyor the correction factor per 1 degree Celsius is 0.000081. So we just multiply that one with 5. So we have got 5 into 0.0081, and we have got a correction of 0.000405, right? And we just, because our temperature is increasing, normally the density will decrease, so we'll just subtract that one from the density at 25 degrees Celsius, and we get the density at 30 degrees Celsius in ER is 0.820995. So once we get the density, just it is very much straightforward. We just get the volume from the LH table, what is 900 meter cube. We just multiply that one with the density, and we get the weight, right? We get the weight is 0.738.90 metric ton. So in that way we can calculate the weight of a cargo using a specific gravity, right? For you, I have given some example over here. You just do it in your own time, and I have given the answer as well, right? You just practice it, right? I want you to take a picture of that one and you just practice it in your own time. Let's see the last method, which is very commonly used in the USA. So here actually we need to use tables. We need to use petroleum measurement table, right? Or sometimes we call it ASTM table, right? So these petroleum measurement tables are internationally recognized standard tables used to ensure accurate, consistent, and legal defensible measurement of petroleum quantities, right? So once you are quantifying the petroleum, so most of the time you have to use this petroleum measurement tables, and these petroleum measurement tables are jointly developed by API, American Petroleum Institute. So that's why sometimes they are called API table. ASTM, American Society for Testing and Materials. So that's why sometimes they are called as ASTM table. And IP, right? Or Indian Institute, former Institute of Petroleum in the UK, right? So these tables are used to ensure accurate, standardized calculation and to enable conversion between the various units of weight, volume, and density and temperature, right? So if your ship is carrying petroleum cargo, you'll see that you have got in your this ASTM table in your CCR. Don't worry, right? So for us, for those who are serving on board tanker, especially in oil and chemical tanker, there are some specific ASTM table. We need to look to those tables, and I have given a table for those one. So these I'll show you all those important tables, right? So these petroleum measurement tables are organized in 12 volumes. So you have got 12 volumes, and these volumes collectively cover volume correction factors, density conversion, relationship between volume, mass, density, temperature, and API gravity for a petroleum liquid, right? What is API gravity? I'll discuss it, don't worry. So if you are serving on oil and chemical tanker, right, so you need to have this ASTM table 6B and table 54B, right? Whereas if you are serving only on crude oil tanker, those who are carrying only crude, right, so they have to use table 6A and table 54A, right? So table 6B will give you volume in barrels, temperature in Fahrenheit, API gravity in 60 degree, right? Whereas table 54B will give you volume in meter cube, temperature in Celsius, and density at 15 degree. So we can see that the API gravity actually is another way of giving you density. Whereas if you are using table 6A, you'll get volume in barrels, temperature in Fahrenheit, API gravity in 60 degree Fahrenheit. And if you use table 54A, you will get volume in meter cube, temperature in Celsius, density in 15 degrees Celsius. Right. Beside that, you need to have other tables as well. Table 1, which you'll get in volume 11. So here actually you'll get the interrelation of unit of measurements. So this table 1 will give you long tons to metric tons and vice versa, right? And because this long tons, actually if you calculate the volume in barrels, then if you convert it, actually you get the weight in long tons, which is normally used in USA. So if you want to get it transfer it to the metric ton, actually you need to have table 1, and you need to have table 11 as well. So this table 11 will give you the long tons per barrels and US gallon as 60 degree Fahrenheit, right? So it will provide weight correction factor as 60 degree Fahrenheit, right? So it will tell you long tons per barrel, right? Per barrel how much long tons is there. And you need to have table 56. It will give you kg per cubic meter and cubic meter per ton against density 15 degrees Celsius, right? It will give you cubic meter per ton against density at 15 degrees Celsius. So these are the tables are very much important if you are serving on either in oil tanker or chemical tanker or crude oil tanker. So you need to have all those tables. So I have seen lot of chief officers actually they keep a soft copy of these tables, right? Even I have the soft copy of these tables in my own drive. So try to keep those soft copies in your drive. So before starting the calculation, let us get some conception clear. So let us see what is API gravity. So API gravity is a standard measure developed by the American Petroleum Institute to express how heavy or light a petroleum liquid is compared to water. So it's kind of like another type of another way of expressing specific gravity, right? So so obviously they have got their own way of expressing it and own formula. So API gravity is an inverse measure of the density of petroleum liquid relative to water, right? So that means if your API gravity is higher, the oil will be lighter, right? And if your API gravity is lower, then your oil will be higher, right? So formula for that one is API gravity is equal to 141 divided by relative density at 60 degree Fahrenheit minus 131.5, right? So suppose if you are comparing if you are getting the API gravity of water, so in that case relative density of water at 60 degree Fahrenheit is 1. So so we get the API gravity is 10, right? So which means if you have a petroleum liquid which has got API gravity of more than 10, that means that petroleum is lighter than the water and that petroleum will float. Whereas if you have got a petroleum liquid which has got API gravity less than 10, that means that petroleum liquid will be heavier than the water and it will sink. So calculation of API gravity, how to calculate the API gravity. So calculate the API gravity of an oil which has got a relative density is 0.8. I want you to just do that one. How to do that one? You just do it by 141 divided by relative density minus 131, right? So that's actually you do it by that previous formula I have given. So there are some definitions we use or term we use to calculate the weight of the cargo by API gravity. Let's see what are those terms. So the first term is gross observed volume. What is that? So it is the total volume of petroleum product including water in suspension and sediment but excluding free water, right? So what is free water? Free water is a water which has settled out and can be measured as an ullage or interface. So free water is a water actually which is settled, right? So actually we can get that free water out anytime. And gross observed standard volume is a volume which is converted to the volume at the standard temperature, usually at 15 degrees Celsius or 60 degree Fahrenheit. And gross standard mass is the mass of the gross standard volume, and gross standard weight is the weight of the gross standard volume. So these are the terms actually we need to know before starting the calculation, right? So like um, other type, here also you follow a pro forma. What are the pro forma we use? We get the gross observed volume from ALES table, right? It is very easy. We just take the ALES and get the volume from the ALES table, then get the volume correction factor table from ESTM table 6b, right? So we just get the volume correction factor. It is not table actually, it is factor, right? So get the volume correction factor from AS table 6b, and what you need to do, you just multiply that one with gross observed volume, and you get the gross standard volume as 60 degree Fahrenheit. We'll see that one, don't worry, right? I want you to write down this pro forma so that it will help you to get your calculation done. Then you get the weight correction factor from table 11, and once you get the weight correction factor, you just multiply that one with the gross standard volume and get the weight of the cargo in long tons. So once you get the long tons, what you need to do is just get the constant from table 1 and you get it into metric ton, right? And you just how to get that, and that constant is 0.984206. You just divide that long ton by that 0.984206 and you get the metric ton. So let us see one by one step. First step is to get the gross observed volume from ALES table. So suppose you got a cargo and you got the so you got a cargo which has got a volume of 5232 barrels of gasoline. API is 66 and temperature is 90 degree Fahrenheit. So these are the thing actually the surveyor has given you, right? And you have got this volume from your ALES table in barrels, right? So you have got 5232 barrels and 95 degree Fahrenheit, because this 95 is your loading temperature, right? So now what you do, you just get the volume correction factor for 95 degrees Celsius, 95 degree Fahrenheit, and you get it 9.9748. How you get it? Let us go to table 6b. So for 6b you get a the table will look like that. So you need to go to API gravity, because your API gravity is 66 and you need to go 95 degree Fahrenheit, and you get the correction factor 9748. So once you get the 97 correction factor, what you just multiply that one and you find the gross standard volume at 60 degree Fahrenheit, right? So once you get the gross standard volume at 60 degree Fahrenheit, what you need to do, you need to get the weight correction factor, and you get that weight correction factor from volume 11, right? So how you get it? You go to volume 11 and you need to go to that table 11, and you need to go that column like long tons per barrel, and as your API gravity is 66, you get that one and you get the weight correction factor 11182, right? You just multiply that one with weight correction factor 11182 and you get the weight of the cargo. So that weight is on the long tons 570.29, right? So once you get it on the long ton, you just divided it by a constant, and you finally you get the metric ton, and that constant is 0.9841. You can keep it, write it down in your cargo notebook or in your CCR, or you just get it from the table, right? From that, and you table 1, right? So yeah, once you divide that one with the constant, you get the weight of the cargo, and weight of the cargo is finally 579.44 metric ton, right? So here you get the table 1. So here you see you get the metric ton to long ton. So you just divide it 0.984206, or you can use that one as well, right? Long tons to metric ton, right? So you just multiply that one 1.01605. You just multiply that one and you get the metric ton. So in that way actually you you calculate your cargo, right? So if you want to practice more, I want you to take a picture of this slide, right? So here you have got 4 questions and you have got some answers as well. You just try in your own time, and I have got some other questions as well. Here we have got total 7 questions. You just take the picture of those and prepare it or practice it in your own time. I have given you the answer as well, right? So as a chiefmate, what you need to do, you need to prepare the cargo officer. But if you're a junior officer, right, so you should not, you can prepare the cargo document, but you should not involve yourself in signing the cargo document. And if anyone gives you the documents and if he tells you to sign it, I will advise you that you just notify the chief officer and master and get the advice from them and then sign it, or tell chief officer or master to sign it, right? And there is a normal standard way of handling this discrepancy, right? So in normal operation in tanker, the ship's calculated figure should be within plus minus 0.5% of the BL quantity, right? So if the ship's load figure is less than 0.5% of the BL figure or provisional shore figure, then as a chief officer or as a master, what you need to do, you need to issue a letter of protest with regard to the cargo discrepancy. Hope this lecture will help you to understand the cargo calculation on board, and I will continue with some other topic which is related with the operation side of tanker, and hope to see you in the next lecture. Thank you very much.